Hey there. So I created a new statistic called adjusted slugging percentage. Um, so slugging percentage is a way to compare players' batting performance, and it's similar to batting average, but the difference with slugging percentage is that it weights better hits more heavily. So home runs are hit or are weighted 4 times as well as just like a regular single hit, whereas in batting average they are all uh, weighted equally. So this works great in theory, but the problem with this is that if a player, for example, plays a course stadium um, where it's much easier to make like home runs, for example, than somewhere in like Miami, the player at Coors will have a much higher slugging percentage than the player at Miami, even if their actual skills are comparable. So what this project does is that it takes into account park factors for each game that a player plays in within a season, and then adjusts the slugging percentage uh, by that park. Um, so we use Statcast data, and we look at each game that a player plays in, um, and we calculate the total bases they get, and then we multiply that by the park factor for that stadium. We also take into account if they're left or right-handed by which side they stand in at the plate, since there's different park factors for those different or left and like right-handed players. And actually, in some cases, it's pretty large. So we also take that into account. So really, what this gives us is a much better way to compare players across an entire season um, than just simple slugging percentage. So I'll go through this code. So this is some of the code here. I don't know if you want to see this, so I won't spend a lot of time. I won't spend really any time. But here's like kind of where we grab some of the park factors, and I just grabbed it from this website that this dude made over here, which is really nice. Initially, I was going to calculate all these park factors myself, but it was really great that I could just take it from there. You can see that we have like left and right-handed ones, and then we do all the calculations here to calculate it. Um, and I also created this little front end React app here, and you can go ahead and we can select like a season, so we can select like 2016, for example, and it generates this whole table of all the players and their slugging percentages, and then their adjusted slugging percentages, and also their total bases hits and at bats where it's calculated. I'm just gonna take a step here. And on the left, we can also search for players if we want like specific ones without having to scroll through the little table, or you can like click on to sort, that kind of thing. You can see that adjusted slugging percentage is sometimes a little bit higher than classic slugging percentage, and sometimes it's a little bit lower. So it does actually matter where these players are hitting. So it's not a huge amount. Like generally, the top player is still going to be the best. The top SLG player is still going to have the highest ASLG. But there are certain circumstances where if two players are close, that it can make a difference. I calculated a correlation score between the two here, and we can see that it's like 99%. So it's like really close. But in the cases where you have two very similar players, this could make a difference. We do have a slight problem with this in that you can see that these SLG numbers are way lower than they're supposed to be. I don't really know why that is. I spent a long time trying to figure it out. As far as I can see, I'm calculating everything correctly, and um, everything's working properly. So the only thing I can think of is that the StatCast data is a little funky or something, or maybe they're counting like uh, hits that aren't hits. I don't know, but so I saw that, and that's a little disappointing because I really want to see how like this calculated ASLG compares to the actual SLG, but I can't really do that since it's so far off. Even in the relative the rankings is a little off here too. Like these are the top players for SLG, and only a couple of these like top 10 players are within like the top 30 of the 2016 season from like the MLB website. So it could be even like we're calculating it differently. I don't know what their data is. We could be using different equations. Maybe I saw online that there's a couple of different ways to calculate SLG. Um, but yeah. Anyways, that's all I got. Just want to make sure I'm not missing anything. Yeah, I think that's it so far. It was a fun project and a fun class. So thanks for that. Alrighty, bye bye.